Hi everybody, this is Morgan here with Positive Approach to Math. Moving right along in our equations topic, we're going to talk about solving absolute value equations today. So just a friendly reminder, if you go below in the details, there will be a PDF of this lesson and the U-Tries that you can download to use at your convenience. There will be a PDF of the answer key of the U-Tries, so if you're trying them on your own or you need some extra practice and you are just trying to prepare, you can check your work. And there will be a video of the U-Tries. So just in case you're looking for practice or you want to try them on your own after this lesson and you get stuck on one or two, please feel free to watch that video to help you. That will also pop up at the end for you to click on. So we're going to get rocking and rolling with absolute value equations. I think you're going to find this as a breath of fresh air. From what we just did, they're going to be sweet and simple, but there's just one little thing we have to make sure we do. So let's dive right into that. So hopefully you talked about absolute value before in pre-algebra or at the start when you were doing order of operations. You maybe saw a couple values with absolute value or a couple expressions with absolute value in them. But the absolute value is the distance, I'm going to highlight this, between a number and zero. So I like to think of the ground, right? Go outside, the grass being zero, right? And so if I build something and I measure its height, that's the distance from the ground, right? And when I tell you the height of my shed or whatever it might be, I would say it is 10 feet, right? So from the ground, from the grass, to the height of, or the top of my shed, that will give me the height. And I give it to you as a number and it's positive, 10 feet. Now, say I'm at the ground and instead I'm going to dig a hole, right? And I'm gonna put an in-ground pool in, right? So I'm gonna dig and I want my pool to be 5 feet deep, right? The low end or something along those lines. I'm not gonna say, oh, my pool's negative 5 feet, right? The distance from that grass from point 0 to the bottom of my low end, I tell people is 5 feet. I don't say it is negative 5 feet because when I'm measuring a distance, I use positive values because I'm talking about from that ground, from that grass to the depth of the pool. So whenever we see absolute values, that's kind of like an abstract of what absolute value is. It's telling us the distance between a number and 0. So numbers travel to the right of 0 in that positive direction, but they also travel to the left of 0 in that negative direction. And their distance from 0, as they go farther and farther away, their distance will be positive in whatever direction because we don't give distance as a negative value, okay? So I did a little number line here. So you'll see that if I have a point marked at positive 3, if I went to count how many ticks from 0 that is, I would say, oh, it's 3 ticks away from 0. Now, if I put a point at that negative 3 and I go to count, oh, look, that's 1, 2, 3. It's also 3 ticks away from 0. It just traveled to the left in the negative direction. But when I tell you its distance, I don't say, oh, it's negative 3 to the left. I say, or I don't say it's negative 3 from 0. I say it's 3 from 0, but to the left in that direction of the negatives, right? So when hopefully you recognize that absolute value means we have those bars, right? And when we have an absolute value equation, it means that we have at least one set of bars in our equation. So we have the absolute value and the variable x is within those absolute value bars. So we see this at least in some way, shape, or form somewhere in our equation. What's important is that when we have absolute value, that we set up 2 equations because we have to account for the absolute value traveling to the right of 0, the positive direction, and we have to account for the absolute value traveling to the left of 0 in the negative direction. So the reason why we have to account for both of those directions is because, I'm going to give you a little model here. If I have the absolute value of 3, that's equal to 3, right? You take what's on the inside and you make it positive. And same thing goes for negative 3. If you have the absolute value of negative 3, that answer ends up being positive 3. So you have to account for what's inside those bars to be positive or negative, because when you go to take the absolute value of them, it's going to spit back that positive. So let's dive right into the first example, and I'll talk about that a little bit more. So when we set up our two equations, we need to make sure that the absolute value is isolated. And I like to think of the absolute value as a house. So we want to see that house, and I am going to highlight that house. And I'm going to draw my famous orange line down the equal sign, and I'm going to say, okay, look at that left-hand side. Is the house the only thing you see on that left-hand side? Meaning, is there something in the front yard, so something in front of those bars, or is there anything in the backyard, something behind those bars? And the answer to both of those questions is no, there's nothing in the front and there's nothing in the back. So the bars are isolated. So now you're ready to set up your two equations. And so, in fact, I'm going to undo that line, and I'm going to set up my two equations first. So what I do is I take what's on the inside, I can drop the bars, and I write it exactly as is. I just get rid of those bars, okay? And now I'm going to do a squiggle to differentiate that I'm setting up a second equation. And in this second equation, I'm going to take what's on the bars, and I'm going to say, remember, that x minus 4 can end up being negative 7 because the absolute value of negative 7 is still positive 7. So I'm going to set it equal, what if the inside of the bars leaves me with negative 7? The absolute value of negative 7 would still give me positive 7. So I need to account for the inside of the bars to be positive 7 and the inside of the bars to be negative 7, because when I take the absolute value of either positive 7 or negative 7, the distance is just 7, right? If I travel to the right of 0 by 7, or I travel to the left of 0 by negative 7, the distance is 7, okay? So now we have two equations. So now, and this is easy peasy, one step for both of them. So now I'm ready to get x by itself. The opposite of minus 4 is to add 4. Draw my arrow. 7 plus 4 is 11. We do not want to just assume that that equation on the right is going to give us negative 11, so I don't have to say, oh, so therefore x equals negative 11. That's not the case. So if I look at my second equation, go to put my x in the box, I go to add 4, bring my box down, negative 7 plus 4 is negative 3. And so if I go to write this as a solution set, my two values for x are negative 3 and positive 11. And I like to put my smaller number first just to have it, okay? So when x is negative 3 or when x is positive 11, if I substitute them in, that's going to leave me with the absolute value of either positive 7 on the inside or the absolute value of negative 7. And when I take the absolute value of positive or negative 7, I'll be left with that positive 7, okay? All right, let's look at our next example here. So first and foremost, I'm going to draw like a little line. I guess they don't have to be as dramatic as that first example. And I will highlight the absolute value. And so my question to you is, do we see anything other than that absolute value on the left-hand side? Do we see anything in front of that first bar? Anything in the front yard? No. And then that bar in the back, do we see anything that follows after it? And the answer is no. So the absolute value is already isolated for us. So we're good to go to set up our two equations. So the first equation, we're going to account for the absolute value traveling in the positive direction. So we can take 3x plus 6 and just set it equal to 18. So all we do is we just drop the bars, okay? Draw my squiggle here. And then our second equation, We're going to account for that absolute value. What happens if what's inside those bars is negative 18, right? Because the absolute value of negative 18 still leaves us with positive 18. So we want to account for that. Okay. So now we're going to solve, and hopefully you recognize, oh, these are two-step equations. So hopefully you can solve these on your own, which if you can, please fast forward and just solve on your own. And I'm going to just go through it a little bit quicker. So we put that 3x in the box. We need to get rid of that plus 6. So we're going to subtract 6. 18 minus 6 is 12. Then we're going to divide both sides by 3. And so we're left with x equals 4. And now we have to do that same thing to the second equation. So that's why I do the squiggle, because I don't want you to think, oh, I just need to subtract 6 here and here, right? Like I don't want you to mix up the two problems. Those are two separate equations. So now I have to do that process all over again for this equation. So I'm going to put the 3x in the box. I'm going to go and subtract 6. Bring my 3x down. That's going to give me negative 24. And then we're going to go ahead and divide by 3. That's going to give me x equals negative 8. And so my solution set, what will satisfy this absolute value equation is when x is equal to negative 8 or when x is equal to positive 4. That will leave me with an absolute value of either 18 or negative 18. And when I take the absolute value of 18 or negative 18, I'm just left with positive 18. Okay? So it looks really intense when you're looking here. You're like, wow, we're doing lots and lots of math. And we are, right? It's just not as scary as it looks. Okay. Next example, I draw my little line to get me started. I'm going to highlight my absolute value bar. Maybe you see where we're going here. I see my absolute value or I see my house. I ask myself, is there, looking at this first bar here, is there anything in front of that in the front yard? No, there is not. Good. Looking at the back bar, the back of the house, is there anything in the backyard that follows to the right of it that's still on that same side? And there is. There's a minus 4. So I am not ready to set up my two equations yet. I have to get my house or my absolute value by itself. So I have to do a little bit of work here. I'm going to go ahead and add 4. I need to move that minus 4 over, so I do the opposite operation. And so I'm going to do that on both sides. That's going to leave me, let's see if I can write teeny tiny, or teeny tiny for me, I guess. 17 plus 4 will leave me with 21. Now when I look at that, there's nothing in the front and there's nothing in the back. So the absolute value is now isolated. So now we're ready to set up our two equations. So our first one, we account for 2x minus 5 to see if it would end up being positive 21. And then we're going to account for what if what's inside those bars is negative 21, because that will still leave us with a positive as our answer. So we're accounting for both of them. Only difference from this problem is it had something in the backyard, so we had to move it over first. And it was being subtracted, and so we know the inverse of subtraction is addition. So I'm going to go ahead and start solving this. Hopefully this is a piece of cake at this point. We need to bring over that minus 5, so we're going to add 5. 21 plus 5 is 26. And then we're going to divide both sides by 2. And we get x equals 13. Awesome, awesome. Okay, next problem. We're going to add 5 to negative 21. Bring down that 2x. Negative 21 plus 5. Is that what I'm doing? Yep, is going to give us negative 16. And now we're going to divide both sides by 2. Negative 16 divided by positive 2 is negative 8. And so our solution set, the thing that will make this equation true, we have two values. X can equal negative 8. I'm squeezing it right at the top here. Or X can be 13. And I just use those little brackets. Okay? So hopefully that you were good to go with that. So always check front and backyard. They might try to sneak that over on you, especially if it's multiple choice. They will give you an answer where they did not get rid of that backyard first. Okay. Next, we draw my little line. I highlight. Okay. So now I'm ready to ask you, I see that front bar. Is there anything in front of it? And hopefully you're thinking yes. But let's talk about how it's in front of it. So it is glued together, right? It is 6 and then a bar, and there is no operation between them. So that tells me that that 6 is being multiplied by that absolute value. So if I want to undo that multiplication, I'm going to have to divide it. But before we divide it, let's make sure there's nothing in the backyard. So is there anything to the right of that back bar? No. So we only have that 6. So what we're going to do is we're going to undo that multiplication, and we're going to divide both sides by 6. Okay? And so that's going to get rid of that for us. So we're going to be left with the absolute value of x plus 2. And negative 18 divided by positive 6 is negative 3. Now, we like this problem because it's not going to require much work, okay? Absolute values are always positive. We talked about that because we're talking about the distance from 0. So it is not possible to take an absolute value and have it equal a negative number. Not possible. Absolute value of anything is always positive. The absolute value of negative 5 is positive 5. The absolute value of positive 5 is 5, right? So when you see, once your house is isolated and you see nothing in the front yard, nothing in the backyard, if it equals a negative, and I always do I spy and look for these first, the answer is no solution. There is no number that I can substitute in for x that when I take the absolute value of that number plus 2, it will spit back negative 3 because the absolute value can never equal a negative. However, it's super duper important that you make sure your house is isolated before you look for this. So because if I would have divided by negative 6, I would have done negative 18 divided by negative 6, and that would have left me with positive 3, and then it's a go, right? So make sure your house is isolated and isolate it properly, and then examine, okay, do I see any absolute values equal to a negative? Because an absolute value can never be equal to a negative. So I don't waste time setting up two equations because it's not a possibility. So we don't have a solution for that problem, okay? So this is a good little summary here that kind of wraps up all that we've talked about. So you want to first, whenever you see those bars, I need you to know you're setting up two equations. And in order to set up those two equations, you really, really, really want to make sure that that absolute value, that house is isolated. Nothing in the front yard, nothing in the backyard. If it's not isolated, isolate it. Once you're ready to set up your two equations, the first equation, all we do is drop the bars. Keep as is. Absolute value equal to a positive, okay? Second equation, absolute value if it's equal to a negative. So we just flip the signs of the right-hand side, okay? Once your house is isolated, if your absolute value is equal to a negative, there will be no solution. And then finally, make sure we write our answer as a solution set. Obviously, we couldn't write a solution set for the last example, okay? So I left you some fun problems. Look at those 6 problems there. There's some good stuff happening. So give those a try to make sure you have this skill down, or if you just want some extra practice. And if you have questions, hopefully my video of those 6 problems will answer them, or my answer key. But keep up the great work, right? So all those skills that we've been adding to our toolkit are really coming to play and making things go really simply for us. So awesome work, and I'm super proud of you.